I'm delighted to welcome you to NTU Singapore. Where you spend the next few years of your life is one of the major decisions facing you. So my one piece of heartful advice, please choose the university that offers the best fit for you. Many universities may look similar, but here I would like to outline for you NTU's distinctive strengths and how it differs from the rest. The COVID-19 pandemic has reinforced the role of universities in providing critically needed and timely information, scientific know-how, and support to policymakers and governments. We aim to be a great global university founded on science and technology, nurturing leaders, and creating societal impact through the interdisciplinary education that includes humanities, the arts, social sciences, business, and medicine. To accomplish this goal, we launched an important initiative, NTU 2025, which is our 5-year strategic plan, earlier in January this year. NTU 2025 will establish specific pathways and initiatives to strengthen NTU's 4 core pillars: education, research, innovation, and community. Educating and training the next generation of thinkers, innovators, leaders, and lifelong learners is central to our mission. We will intensify our focus on interdisciplinary approaches across both education and research, and expand holistic learning opportunities for students through a variety of mechanisms. These include new interdisciplinary programs, new approaches for industry internships for all undergraduate students starting this year, new learning spaces and models that tap into advances in the science, art, and technology of learning, new industry-relevant, modular, continuing education course offerings. Set to nurture leaders with character, competence, and cognitive agility, a carefully designed interdisciplinary core curriculum will be launched later this year to emphasize digital literacy, teamwork, communication skills, experiential learning, and global citizenship. We will equip NTU students with the skills and knowledge necessary to thrive in a rapidly changing workplace and in rapidly changing living environments to be future-ready graduates. Looking beyond grades, NTU offers many programs outside of the classroom that provide experiential learning. Your development will not be confined to academics. You will also grow as artists, musicians, athletes, and socially engaged citizens. Research and education activities will be integrated more closely, giving students increased opportunities to engage in research and creative work in their undergraduate journey. On this campus, you will find industry leaders such as HP Inc., Rolls-Royce, and Volvo conducting cutting-edge research and technology development together with our faculty, staff, and students. This research also tackles some of the most complex challenges that society faces in such areas as sustainable energy sources, aging, food security, cybersecurity, and climate change. Last month, as you may have heard, scientists in NTU reported that they have created a way for humans and plants to communicate with each other. This research opens the door to new technologies that make use of plants. So please don't be alarmed to see some students or even professors talking to our trees on our beautiful campus with lush greenery. This seemingly unusual behavior could be part of groundbreaking research. As a leading provider of continuing education, we will help students navigate through the dynamic changes in the workplace and develop a mindset that prepares them for lifelong learning. We aim to share NTU's unique strengths in educational research, EdTech, science of learning, and pedagogical techniques through strategic collaborations with other institutions. In the coming years, my colleagues and I look forward to supporting your intellectual pursuits, nurturing your success in your academic achievements as well as extracurricular pursuits, and learning about the social issues that inspire you to action. At NTU, you will learn, live, play, and build lifelong memories and friendships in a beautiful and welcoming campus, which is a small city. I invite you all to participate in this extraordinary journey. Thank you.
Good morning, everybody! The Earth says hello! Welcome to the e-Open House for Nanyang Technological University's School of Physical and Mathematical Sciences, also known as SPMS! Woo! We're here right now with the Chemistry and Biological Chemistry Division, also known as CBC! Woo! So compared to the virtual open house that we had earlier on in February, this e-open house will be a slightly more chill, more casual version, and most importantly, it is an invite-only session that is specially created for all you prospective students. My name is MJ. I'm the co-founder of a science channel called Just Keep Thinking, and I will be your MC for today. Woo! Okay, I know it's in the morning, guys. Some of you are sleepy. Some of you are probably dozing off in front of the computer. But so sweet, y'all kena the morning slot. But that's okay. That means you guys will get to end earlier as well. So just grab a coffee, slap yourself up if you have to, because it will be an informative and hopefully mildly entertaining session for the next 1.5 hours. So let's get right into it. Speaking about chemistry, it brings back a lot of bittersweet memories for me because I remember struggling a lot with this topic. I got my first and only ever C grade for a biological chemistry module back in my university days. There were so many benzene rings to remember. There's so many benzene rings to draw. Every line you draw in the benzene ring means something else. But it's okay. Hopefully, today I'll gain more insight from our panel of speakers, starting off with the first speaker of the day, Associate Professor Tan Hao Xiang, who will be giving a general introduction to the CBC division. Also, if you guys have any questions, you may type your questions below so that we may answer them during our Q&A segment later on through Slido. Also, you may type your questions via CBC's Telegram channel at NTU_chemistry. Without further ado, let's get the ball rolling by inviting our first speaker. Prof. Tam, whenever you're ready.
All right, thank you, MJ. Wow, that really woke me up. I really need that high energy after, like a long night of sleep and some coffee. But anyway, so I'm here. My name's Hao Xiang. I'm an associate professor at the chemistry division of biological chemistry and chemistry, right? Actually, we short form it and call it NTU chemistry, just to keep it sweet and short. So I teach physical chemistry in the chemistry department of NTU, and I'm here to basically give you some idea of what our division actually is all about, right? Since you guys may be thinking of joining our big family. So I guess it makes sense for you to know a little bit more about us. So how shall I begin? So what do we do, right? So if we are saying that we are a division in chemistry or biological chemistry in NTU in School of Physical and Mathematical Sciences, what do we actually do? Well, we in chemistry at NTU are a whole group of people who are interested in anything molecular, right? Anything that molecules are made of, how they are made, why they are there for, how do you make materials out of molecules, and the what for of it, the why, the what, the how, and what for of all things molecular. So anybody who's a fanatic of molecules, that's the correct place to be. And that is us. And to be more concrete, just a brief introduction of ourselves. We are actually not that old, 16 years old, founded in 2005, together with the founding of the School of Physical and Mathematical Sciences, SPMS, if I got that correct. And we are a molecular family of like about 814 undergrads. If you can add the math, you can see that we're about 1,000 strong, right? Including 800 odd undergrads of all years, almost 100 PhD and master students, and 31 faculty members that are the professors and lecturers doing research. And to help them off, there's 80 research staff, postdocs, and so on and so forth. And of course, to make this whole thing work perfectly, we have 13 admin staff to help us along. And so if you join us, it's like a family. So of course, the next thing you're going to ask is, what is this family business about, right? You know, you want to join us, what do we do? Well, here is a kind of a brief outline, a very general sweep of it. So we are, of course, you know, specialized in understanding the fundamental science of molecules, how they work, what are they, how do you make them, and what are they used for. Right, you may think that this is all textbook stuff, you know, very boring stuff, going to the lab. Of course, I don't think that you think it's boring, but someone may think that it's boring. But apart from that, we are also very widely deeply connected to the world. It's not just for the fun of making molecules that we make them. Of course, we have fun making them, but we find a lot of applications to actually contribute to society. We help solve the problems of 21st century. There you can see the many problems that pop up in your head that you hear about: sustainable development, health and discovery of new drugs, especially in times of COVID, all these things. And of course, other challenges that will emerge in the 21st century. So it is through this feedback loop, like where we develop science and find applications, and then from the applications, we then build into our understanding more about the molecular world that keep us going. That is the fundamental business of chemistry. Now, of course, then where you may think, then where do undergrad students come in? They come right smack in the middle of the action. Through this process of fundamental research, development, and applications to the challenges in the outside world, we provide a environment for undergraduates to actually learn about new chemistry that's coming up, to train them in their logical thinking, the fundamental chemistry skills, which my colleague later will give you a much more detailed outline in the kind of like what is to be expected in the few years that you'll be in NTU chemistry. So there you are. That's roughly the vague thing for how, or rather the general outline of how it goes. And how do we do this research? Now, you may remember that we have 31 faculty members, professors and lecturers. So if you will, they are kind of you could say that they are the big brothers and sisters of the division. And they provide the research directions. And each of them, 31 of them, runs a research group, and basically indulging in different branches of like science and molecular, the science of molecules and so on and so forth. So I'll just basically briefly go through some of these more exciting stuff to give you an idea what, again, the fundamental business of chemistry at NTU. So let's start with this fascinating lady here. So she is Professor Ling Xing Yi. She's actually my boss. She's the head of division. And her specialty is actually in nanochemistry. You may have heard of this thing, nanoscience, nanomaterials, and so on and so forth. She is, her fundamental research is in this, and she specializes in making really small units of nanoscale materials of all sorts of shapes and sizes, and then find very good application to it. So over here, we just flash a few. So you can see on the center of the screen how they can packet all these nanomaterial, arrange them in very small arrays, and then implant them on banknotes. So that may be the future of like anti-counterfeiting. And she has also found recent applications of some of these materials to actually help in medical sciences. In this case, identifying chemicals that's relevant to pregnancy and miscarriages. So very important application. And actually much more recently, this is even more important. This only flashed, they came up in a couple of late last month of her research, and then rapid development into this kind of like breath analyzer to actually and I see that I spelled analyzer wrongly, but doesn't matter. I'm a professor of chemistry, not of spelling. That they can use all these particles to actually enhance spectroscopic identification of chemicals that has to do with COVID-19, and hence offer a non-invasive and fast way of like, getting to know whether you had COVID or not. Very useful, right? So that's how you can see how science, fundamental science, can actually impact on our daily life and society, and in times of crisis like now. So here's another more long-term example, right? Professor Su Hansen specializes in inorganic chemistry. So you may learn about inorganic chemistry, D elements and all those things. May sound boring, but they are actually very useful, okay? So what he specializes is that he actually have this brilliant idea. He was looking at, the problems. Plastics are all clogging up all our seas and everything, and our waterways and so on and so forth. And then he also had this worry, okay, what about fuels? Fuels are running out. So he had this idea, why don't I do the breaking down of plastics, right? That solved one problem. And then the breaking down of the plastics then give me fuels to actually power our, next generation, fossil fuel kind of economy. That's what this specialization is in it, how to break down plastic and make fuels. Other examples such as this, Professor Singh, my good friend Professor Singh does all these, make strange molecules that actually help you identify tumors in cancer patients and so on and so forth, and also make chemical compounds that will actually respond to light and only target let's say tumors in your body when the medicine is going to be very localized release of medicine, right? So that's some of the application. And another friend of mine, Professor Chiba, what he does is that he makes all sorts of funny kinds of molecules. Well, not all sorts of kinds, but they actually partner with Pfizer and drug company to make specialized molecules that only appears in natural compounds, but also there's a cheaper way of if you make it artificially. So he makes invent new chemistry reactions to actually do that. I can go on and on. I'll go maybe a couple more, like another of my colleague who you're going to hear very soon. He specialized in looking in the smallest things that you can see. In fact, so small that not even the ordinary kind of optical microscope can see. He used this technique called super resolution microscopy to actually study important industrial photocatalytic reactions. So if you're tired of wanting to do something that's applicable to real life, you can go into more exoteric stuff. So my good friend here, Professor Lo Zhiheng, he basically makes the fastest, shortest camera that you can see you have in Singapore. In fact, his camera shutter speed is 4 femtosecond. That's a lot of zeros, 14 zeros, 4 times 10 to the power minus 15 seconds, if you know what I mean. Basically to capture the motion of electrons inside molecules. And that's very interesting for fundamental science. If you think about it, as a chemist, we think about chemical bonds breaking and forming. That's how fast chemical bonds break and form. And he can make a camera to actually take a look at these. And I guess that's enough to give you a brief introduction of what we do. And how do you all fit in for undergraduates? Well, you come in 4 years of standard, education, right? Giving you all the details in foundation in your different parts of chemistry, and then in between there are a lot of chances to do research if you wish to. And the best way to educate yourself is actually to do something that nobody else has done before, and that's in research. And there's a lot of opportunities. I flash a few here. Eureka projects, summer projects, your final year projects, and so on and so forth. And besides that, there are also specialized programs that will encourage students who are interested in science and intellectual development to actually go into, such as the Odyssey program. And of course, some of you may be doing CN Young Scholarship Program. So this is a brief shout out for this new program, Odyssey program, that's basically a specialized SPMS only program that enables undergraduates passionate in science to pursue intellectual activities and research with regular intellectual discussions and mentorship by faculty and so on and so forth. So look out for this if you come to NTU chemistry and you're interested in doing research. So just to round off, we don't just train our students to have a job in chemistry after you graduate, okay? We train you guys to actually have a life in chemistry. It's a lifelong kind of pursuit. And that means that when you graduate, or even when you are an undergraduate, you will be viewing and understanding the world and help improving through the molecular perspective. And that's our aim. And it turns out that we are pretty good at these, just to brag a little bit about our rankings and so on and so forth, because like everybody in Singapore loves rankings. We are pretty good at what we do, and that's not just according to us or my father and mother, but it's actually according to very well-respected sources all over the world, such as these: US News, QS World Ranking, and so on and so forth. You can see that we are all, NTU chemistry is very well regarded in these international surveys. So more specifically, this is US News. US News is basically the journal, the magazine in US where all the undergraduates in US check out when they decide where to go for the university education. And that's the international edition, and which basically says that NTU chemistry is the ranked 4th. What was it? I don't see. Yeah, very highly ranked, right? And we were really surprised for that. Well, believe it or not, we're pretty good. And that's the QS ranking, world ranking, and you can see that we are also, among the top 10 over here. Very well, and of course, we're very happy that NUS was also pretty well regarded. And that's just yet another ranking, right? So 10th, not too bad. And this is yet another, this is Nature Index, which is actually specialized in just looking at high impact scientific output. And we are ranked definitely in the top 20 in the world. Pretty good. So I hope I kind of gave you an idea of the business of our division here. And I think the important thing is to stay curious and hungry throughout your life. And I'll leave it to my colleagues later on to give you a brief overview of the academic. And later on, perhaps you'll enjoy another of my colleague, Professor Rod Bates, to teach you something about forensic science. And I'll just hand my voice to MJ. Back to you.
Thank you so much, Prof. Tan, for the rather insightful sharing of what CBC is all about. Actually, Prof. Tan, to be honest, I was really excited to meet you. So he may seem like he knows so much, he's a wealth of experience, but do you know that he's a pretty fun person too? He actually had a magic show program. I'm not sure how many years ago he did it, where there was chemical changes and elephant toothpaste explosion. You're the second coolest prof I've ever met in my life.
Oh, thank you very much.
First is my own. Yes, Prof. Todd, hi. So could you share with us a bit more with what you did during that performance?
Oh, well, yeah, I think you meant our elephant toothpaste performance a couple of years ago that we actually showed to incoming students. Back in the pre-COVID day, we sometimes welcome our freshman students by having a magic show, right? And one of the things that we did is actually we had this reaction. It's actually kind of almost like explosive, but it basically entails blowing up a lot of bubbles in soaked detergent, and that kind of looks like toothpaste blowing up. So it's a very fun experiment, and it actually also illustrates a very fundamental kind of chemical principle, thermodynamics as well as kinetics and catalysis in general. But I'm boring you guys now. So I think I'll hand. I think you may want to get Zheng Yang to talk about the academic program, which is more interesting, I guess.
Well, if you guys join NTU Chemistry, you might eventually get to see one of Prof. Tan's magic show performance. Okay, thank you so much, Prof. Tan. Next up, we have Dr. Zheng Yang, who will be sharing more about the curriculum aspects of CBC's undergraduate program. Basically, what you have to potentially mark for the next 3 to 4 years. Dr. Zhang, whenever you're ready, you may begin.
All right, thank you, MJ. So, good morning, everyone. Good morning, everyone. So, my name is Zheng Yang. I'm a lecturer in the Division of Chemistry and Biological Chemistry, School of Physical and Mathematical Sciences in NTU. So today I'll be happy to share with you the academic program that we have for you in CBC itself. So on average, we have approximately 200 students who we will take in every single year. They'll go through a 4 years direct honors program. So at the end of the 4 years, students will then graduate with an honors degree. And this is known as the Bachelor's of Science in Chemistry and Biological Chemistry. So on top of that, if you are more adventurous, you have a bigger appetite, then you may consider to take a second major program that we offer. So we have 3 second major programs. So the first second major program is in Food Science and Technology. So this is a collaborative program with different schools in NTU such as the School of Biological Sciences and also the School of Chemical and Biomedical Engineering. So the biggest partner in this joint venture is actually a university in Netherlands that is famous for its food science program, and that is the Wageningen University and Research. So the aim of this program is to train students, chemists, such that they have knowledge on the food process engineering that is related to the industry. And then the second major program that we have for you is in environmental sciences. So this is a joint program with the Asian School of Engineering and also the School of Civil and Environmental Engineering. So as you know, environmental issues are of great concerns. So we have a direct impact on our environment in terms of pollution in the oceans and also global climate changes. And hence, we really want to equip our students with knowledge such that they have better scientific understanding on the changes that the environment go through, and such that when they graduate, they will make informed decisions to avoid and mitigate all these problems. And then lastly, we are excited to roll out this second major program this year. So this is a fresh program that when you're coming in this year, you'll be taking if you're doing the second major, and it is in business and international trading. So this is a joint program again with the School of Nanyang Business School, and also the Center of Excellence in International Trading. All right, so this program is useful for students who are interested in business and also in chemistry. So as you know, Singapore is one of the largest chemical exporter in the world, and the chemical industry contributes to almost 1/3 of the Singapore's manufacturing output every year. All right, so there's a strong demand for students with chemistry knowledge and also with business knowledge as well. Hence, we really want to equip our students with this knowledge such that when they graduate, they are able to take up key positions in executive roles in the companies next time. So something I want to highlight among these three second major programs. So at the end of the third year towards the fourth year, these three second major programs will have typically an overseas learning experience, right? Overseas trip that is fully sponsored by our university. So did you say, where got such good deal? Yes, we actually offer such good deal in CBC itself. So to basically give you an idea of what you'll be studying in the CBC itself, right, here is an overview of a glance of our curriculum itself. So in the first year, basically you'll take the same chemistry modules as the rest of your classmates in organic chemistry, inorganic chemistry, and also physical chemistry. All right, so all these chemistry modules comes with lab itself, and also you are required to take modules in biochemistry as well. And at the end of the first year, as Prof. Tan has mentioned, there's a lot of research opportunities, right? So you are actually encouraged to do a research project, undergraduate research project in one of the chemistry labs with our faculty members, and that is typically what we call a summer research program, which typically lasts around 13 weeks, basically the whole of your summer, right? So on top of the undergraduate teaching labs, there's also a lot of opportunities to get your hands-on experience in research labs as well. Right, so in your second year, you'll take a more advanced topic in organic chemistry, inorganic chemistry, and physical chemistry as well. And in the second year, you also study analytical chemistry. And because you are in a more senior stage in this academic curriculum, hence you'll be doing full chemistry labs as well. So in your first semester, you'll take organic and inorganic chemistry labs full-time, which lasts for 6 hours. And then in the second semester, you'll do physical and analytical chemistry labs. And research opportunities are available, so you are able to do summer research during that period of time as well. So the same happens for third year modules. You study more advanced modules. And then in the final year, right, in year 4, then you are taking, you'll be required to take a more advanced module, a specialization in topics in chemistries contemporary topics and also subdisciplinary topics in chemistry. All right. And then as part of your requirement, graduation requirement, you are required to either undergo a final year project, take up a final year project, or to do a professional internship in the industry. So this final year project and also professional internship lasts typically 1 whole semester. So something I want to highlight to you is that if you're to come in with an A in H2 chemistry, all right, in H2 chemistry, then you are basically exempted from the basic chemistry modules in organic, inorganic, also physical chemistry. And instead of doing that basic modules in chemistry, you'll take one advanced conceptual chemistry course instead. And also, if you will to come in with an A in H2 biology, then you are exempted from the biological, the bio modules in year 1. So if you think about it, with all these exemptions and also with repeating modules every single year for year 2 and year 3 modules, in the end, you will typically be able to graduate earlier than the rest of your classmates ahead of your time. And that means that you get to save money as well, right? Which is a good thing. So to basically elaborate more about the major prescribed elective that you're taking year 4, this is a list of partial list of modules that we offer to our students. And you can see from the list that we really want to equip our students with current topics in chemistry, in the area where the chemistry areas are always evolving. So you can see that there is pharmaceutical chemistry, natural product chemistry, biomedical imaging and sensing, and also recently we just rolled out AI in chemistry, which is something of great interest and demand in the industry. So other than that, we have offered, we offer chemistry electives, all right, that other than CBC students, chemistry students with different majors in NTU can take. So some of these modules are shown here, and some of it consists of lab components that is heavy, such that you can beef up your hands-on skills before you graduate. So to focus more on the industrial experience, all right. So we have 2 programs for you actually. So if students are planning to take a final year project during your 4th year, all right, we will then offer you this program called the professional attachment, which lasts for 10 weeks. So you'll gain practical experience in the industry for 10 weeks, such that even though you were to spend a major amount of time working in research lab in NTU itself, you'll still be connected with the industry by the time you graduate. However, if you prefer to work, spend a longer period of time working in the industry itself, then we can offer you this program called the professional internship, which lasts for 20 weeks, all right, which is slightly longer than 1 semester long. And from there, you can really gain experience in the industry, also apply what you learn in school, in the workplace. All right, so shown below here are lists of companies that our students typically work in. So you can see that there's pharmaceutical companies, there's flavor and fragrance, there is a research institute, and also government agency. So overall, we have a wide array of jobs waiting for you when you graduate. So in line with what we talked about for industrial attachment, all right, we have another program which is pretty new, and it's called a co-op education program. So as the name suggests, co-op education program is basically, to educate our students from the point of view of faculty members in SPMS and also industrial supervisors, right? So we have people in academia and also in the industry educating you chemistry throughout your 4 years in NTU. All right. So typically this is a 50-week long program, and it's very selective. You only offer selected seats to a number of students each year, and the breakdown is shown as such: 10 weeks in the first year, 10 weeks in the second year, and 30 weeks in the third year. All right. So we hope that through this program you can gain industrial experience and also develop professional competencies, in the industry before you graduate. And below are also a list of companies that our students typically worked in for this co-op program. And research experience, we do offer a lot of research experience in CBC itself. So Prof. Tan has already mentioned that we are one of the top universities in the world in terms of doing research and also chemistry education. So what better way to gain or use this top ranking facilities that we have to build up your research experience in NTU, right? So research experience typically lasts in the summer research or the FYP projects, right? And during undergraduate research, you can then pick up cutting edge science and also, more importantly, critical skills, soft skills such as critical thinking, creativity, and also problem solving skills. Something that you'll never be able to do it if you're to only follow the instructional teaching lab where everything is guided and go from step A to step B to step C. Research is basically solving open-ended questions, and this is additional skill that you gain, right? And also, if you do undergraduate research experience, you also receive academic credit as well. And lastly, what better way to learn more about chemistry outside the classroom is to go on exchange, right? To widen your horizon. So students, statistically, almost half of the cohort in CBC go for exchange when the situation allows, in an overseas university to widen their knowledge, immerse in the culture and also experience what is the chemistry education in the foreign universities. All right. So for exchange-wise, you can either do a short exchange which lasts for probably a couple of weeks or a longer one which lasts for 1 semester. So for longer overseas exchange which lasts for 1 semester, you can then basically do study real chemistry or also work in an undergraduate research lab. So which some of our undergraduates have done their FYP in, right? So I will strongly encourage you to go for exchange if possible, such that you can gain more knowledge outside NTU itself. So this is the end of my briefing, and I hope that through this talk you will have a better knowledge on the academic program in CBC itself, and I hope to see you this coming August. Thank you very much.
Thank you, Dr. Zhang, for the curriculum sharing. I was really impressed with the double major program that you guys have where students get to gain knowledge from 2 different fields. How do you think that has helped the new students or will help the new students navigate their way to the problems of the 21st century?
Yeah, so this double major program, before we wrote this, we gather industry partners and to discuss with them what is the actual demand and interest in the industry itself. And then through their feedback, we gather that these are the 3 main areas that the industry typically requires. And hence, we came up with this curriculum such that we are able to equip our students with the knowledge so that when they graduate, they are able to take up key positions and key roles in such industry to solve the problems that the world is currently facing.
Wow, that's amazing. Thank you so much, Dr. Zhang.
Thank you.
Just a reminder for you guys, if you guys have any questions, please do send it in so that we may answer them during our Q&A segment later on. Or you may also ask via CBC's Telegram chat at NTU_chemistry. Okay, moving on to the next CBC speaker of the day, we have Mr. Lee Jin Kai, who will be sharing his undergraduate experience here in NTU CBC division. It should be rather fruitful and exciting, right? I mean, right. We are a live session, you can't say otherwise. Yeah, you have to say something. Joking, that's why he's here. It's a positive experience. So Mr. Lee, whenever you're ready, you may take it away.
Thank you. Hi, good morning, everyone. I'm Jing Kai, and I'm here to share my undergraduate experience with you guys. So, firstly, about myself, I graduated from Singapore Polytechnic with a diploma in perfumery and cosmetic science, and I'll be graduating from NTU CBC this coming June, if everything goes well. Yeah. So that's me in the top right corner of the picture, and those are my research, my lab mates from my same research group, which is under Dr. Zhang Zhenyang, which presented to you just now. So coming from a poly background, I can only tell you how different uni is from a poly student's perspective. So firstly, we have more independence and freedom, such as we are able to plan our own timetable, the courses that we want to take, and also the pace of our own learning, meaning to say that if we find that the curriculum is too fast or too slow, we can choose to take more or lesser modules for ourselves. So next, there are also more activities to try out. There are many CCAs, many of which I never heard of before when I went to the open house. There are also hall activities for us, which Poly doesn't have because Poly don't have hall. Yeah. So hall activities, we can take part in like dance or band or even recreational games such as chess, Scrabble, or sports like badminton and basketball. And then there are also many opportunities to meet new people because we have so many CCAs and also we have so many electives which gives us chances to meet people from other faculties like engineering, business, etc. So this is a good chance to build your network. And most importantly, it requires a lot of self-discipline from our side. Because in uni, there's no one that will hound you to submit your assignments on time or to even attend lectures. So as adults, we should take initiative and be responsible for our own learning and education. So always attend your lectures, even if it's online. Yes. So my most enjoyable part of CBC is actually in the teaching labs, conducting experiments. So every semester we have one module which requires us to do lab, and it will either be organic or physical. So these are the organic labs, and that guy in green there is actually a teaching assistant known as a TA. So there are many TAs who are very approachable and friendly and are always keen to share their knowledge or to even lend a helping hand in the lab. So in my final year, I also became a lab TA and a peer tutor so that I could help my juniors with their studies if needed. But CBC is not just about lab and studying. So I also took part in the inter-school games representing SPMS for badminton. And although we didn't win, it was still a very fun experience for me because I was able to make friends from other divisions such as physics and math. So during my summer vacation after my first year, I went for a summer exchange in Korea. So I did Korean ceramics and Korean level 1 in Ewha Women's University. Yeah, so take note that even if you're a guy, you can apply there for summer exchange or even full semester exchange. And the university students there will be sort of like your tour guide. So yeah, just letting you guys know. So after I came back to Singapore, I continued learning Korean. So I did a minor in Korean language. So I studied up till level 4. And the teachers are really passionate in sharing their culture. And it was also very nice to be in a classroom environment where all the students are interested in the same thing as you. So because of this positive experience in Korea, I wanted to give back that same experience to incoming exchange students to SPMS. So I registered to be a SPMS outreach ambassador. And what we did is we brought exchange students around SPMS facilities to view the different research labs, the different equipments that we have, such as the TEM, SEM, etc. And then the following day, we brought them to view local landmarks such as Chinatown, MBS, Gardens by the Bay. So sadly, this was during the COVID semester and they had to leave halfway, so they were not able to complete their so-called full exchange experience. And then in my final year, I did a FYP, final year project under Dr. Zhang. So final FYP is actually really fun because we get to learn many new things which are not covered in our normal CBC syllabus. So it requires us to be more like self-motivated when it comes to learning. You have to find out things by yourself. Sometimes even your prof also don't know. But it's okay because everyone will learn together. And then, so it's a very fun experience because we can also try our own experiments. We can just make some adjustments ourselves. And this is our group dinner that we had last week at Swee Chun. So my boss was very generous to treat us to some dim sum. Yeah, we ate quite a lot, so I'm sorry. Anyway, yeah, so I feel like I'm very lucky that I was able to find a group of people that I really love working with. So it's a very comfortable environment. It's where everyone, we know that we have to work hard, but when it comes to resting or what, we also play hard together. We enjoy together. And I'm sure that you guys will be able to get that experience too if you were to come to CBC. Yeah, you will find a lab that has a culture and environment suited for yourself. So some of my key takeaways from uni is to make more friends. Never stop making friends. Wherever you go, whatever CCA, whatever elective, just make friends. So you may find a group of friends that you'll be able to click with very well, or you might even find your future boyfriend or girlfriend. Yeah. So don't hesitate to ask for help, because the professors and lecturers and everyone is basically very approachable. They are very helpful. They are there to help you, to educate you, to teach you things. And if you're uncomfortable with that, you can always approach your peer tutors or even those TAs, that kind. So experience new things and try to go for summer or semester exchange if possible. So hopefully the COVID, this situation settles soon, so that you guys are able to do so. And lastly, is to enjoy yourself, because these 4 years will really go by very quickly, much faster than you would expect to, and you should try to make the most of it lah. Yeah. So that's all. Thank you.
Thank you, Mr. Lee, for sharing your undergraduate journey experience. I actually realized, when I talked to you, that you are continuing with your postgraduate studies with Dr. Zhang's lab, right?
Yeah, that's right.
Yeah. Do you know that now his slide, he's like, one of the positive things of joining his lab is get to know your prof. So what made you decide to continue your postgraduate study? Is it?
Yeah, it's actually my boss. He's very nice because he's always there in the lab with us, and then whenever we need help, we can troubleshoot, we can discuss with him. So it's a really, a down to earth kind of discussion where we can interact, not as friends, but there's not a very big this thing, I'm the boss, you are the worker, that kind of environment, So it's very good for us students, and he's also very encouraging lah. He says it's okay to fail, which is what happens to me quite often. So every time I fail, he said it's okay, just try again, and then I will try again. Yeah.
That's amazing. Yeah, having a good mentor to guide you along is really important. Thank you so much, Mr. Lee.
Thank you.
All right, next up, we have something special in store for you guys. It will not be a sharing segment, but it will be a mock lecture by Associate Professor Roderick Bates on forensic science. Yay! I'm super stoked. I'm super excited. I think this is one lecture that you will not fall asleep in. Prof. Bates, the stage is all yours.
Thank you so much. So chemistry is a subject that has many, many different applications, and it can be applied to crime. You can apply chemistry both to committing crimes and also to solving crimes, and that brings us to forensic science. Because many people think that forensic science is really about biology, but actually a lot of forensic science is based on chemistry. And that's why we started a forensic science elective course. This is open to all students at the university, and that of course includes anyone who comes to study chemistry. So what I'm going to do is just introduce you to some of the characters who appear in our forensic science course. So the first one is Colin Pitchfork. Now Colin Pitchfork is very famous in forensic science because he is the first person ever convicted of a crime through DNA evidence. So this goes back to 1983, when a teenage girl was found at a place called Narborough in England in the woods, and she'd been raped and murdered. And back in 1983, there was not much you could do to solve that crime. Then 3 years later, another victim was found, raped and murdered in pretty much the same place. And the police thought that the same man had committed both crimes. And then they got lucky because someone came forward and confessed. A young man called Richard Buckland came forward and confessed to the second crime, but not the first one. Now, the police were convinced that the same person had committed both crimes. Now, by chance, Narborough is near Leicester, which is where Professor Alec Jeffreys works. And he, of course, is the man who invented what we call DNA fingerprinting. So the police sent samples from the two crimes and from Richard Buckland to Alec Jeffreys to analyze. And so Alec Jeffreys came back and said that he'd got good news for them and bad news. The good news was that they were right. The same person had committed both crimes. The bad news was that it wasn't Richard Buckland. Buckland had actually confessed to a crime that he'd not committed. So, how to catch the killer? What they did was to screen every single adult male in that town, sending all these blood samples to Alec Jeffreys to do the DNA analysis. And that is how Colin Pitchfork was caught. But it wasn't that simple. Colin Pitchfork played a trick, and he very nearly got away with murder. But he was caught. And if you want to know what his trick was and why it didn't work, well, you've got to come to CBC and take our forensic science course. Next character, Daniel Holdom. This is an Australian case, and it starts with a suitcase. This suitcase was left by the side of a highway at a place called Wainaka in South Australia. And after months and months and months, eventually somebody opened it up and had a look inside. And what they found inside was some clothing and the skeleton of a little girl. Now, to solve the case, you need to know the identity of the victim. But how can you identify someone who has been reduced to simply a skeleton? Well, it was through this. This is a quilt which was in the suitcase. And this is not just some quilt somebody bought from a store. This was a handmade quilt. In fact, it had been made by the little girl's granny. And because it was handmade, it is a unique object in the world. It is what we call individualized. And when this quilt was shown on Australian TV, a member of the family recognized it, called in, and provided the name of the little girl, Candace Pierce. Now, if a little girl is missing, where's the mother? It turns out the mother had also been murdered. And in fact, her remains, another skeleton, had already been found more than 1,000 kilometers away in New South Wales. And they were able to show that that skeleton was the mother through DNA. And there's the mother, Carly Pierce Stevenson. They had been murdered by Daniel Holdom. Now, how did the police identify Daniel Holdom as a suspect? How did they get a conviction for the two murders? And how did they reconstruct the whole story of how Holdom murdered them and deposited their remains so far apart in different places in Australia? So if you want to know, you've got to come to CBC and take the forensic science course. Okay, the next character is J.G. Haig. Now, J.G. Haig, this is in London back in the 1940s, and he earned a living by making friends with wealthy old ladies, cheating them out of their money, and then murdering them. And he faced the problem that all murderers have. What do you do with the body? And his solution was to use chemistry, specifically concentrated sulfuric acid. And what he would do after he had shot these ladies in the head is that he would dissolve them in concentrated sulfuric acid, and then he would pour the resulting solution down the drains. So how was it proved that Haig was a murderer? Well, it turns out that there are certain parts of the human body which do not dissolve very well in concentrated sulfuric acid. And if you want to know what body parts those are, come to CBC and take our forensic science course. Next character is Graham Young. Graham Young, from when he was quite small, was very interested in chemistry. In particular, he was interested in poisoning. In fact, by the time he was a teenager, he had murdered his stepmother by poisoning her, and he was in a psychiatric hospital. So eventually, the psychiatrists decided that Graham had been cured, and he was released. And he found a job in a warehouse, what we would now call a logistics company. And one of his duties in this warehouse was making tea. And so he used that as an opportunity to continue his chemical experiments. So he would put poison in the tea and see what effect that had on his co-workers. So he didn't really want to kill anyone, he just wanted to see the effect. But he did kill 2 of his co-workers. Now, it was originally thought that these people were getting ill and then dying due to some virus or something like that. And so the bodies of those 2 victims were actually cremated before there was ever a police investigation. But people became suspicious, and eventually Graham Young was convicted of the 2 murders, and he spent the rest of his life in prison. Now, the reason that the police were able to get forensic evidence to convict Graham Young was because he used a poison called thallium, which was easily obtainable in those days because it was used as rat poison. And there is a very fundamental chemical principle that allowed the forensic scientists to prove that Graham Young used thallium. If you want to know what that principle was, come to CBC and take our forensic science course. So the last person I'll introduce you to is Adam. Unlike the first 4, Adam was not a criminal, Adam was the victim. So his body was found on the bank of the River Thames in London, but without the head, without the arms, without the legs, just wearing a pair of orange shorts. So what can forensic science do in order to identify Adam so that his killer can then be caught? Well, you can examine the shorts. They're made in China. They were sold in West Germany. You can examine the stomach contents, and the stomach contents told the police that this was not an ordinary murder. This was actually West African black magic. What they also did was chemical analysis of Adam's bones. Now, as you all know, the principal inorganic element in bones is calcium. But your bones also take up all sorts of trace elements from the environment. And those trace elements are characteristic of where you grow up, or at least they're characteristic of where your food grows. And they were able to show that Adam wasn't just from West Africa, he was from a very specific region of Nigeria. And he had been smuggled to London via West Germany for a black magic ceremony. So if you want to know who was Adam, and if you want to know who killed Adam, well, you can come to CBC and take this course, but we won't be able to tell you. Because even though forensic science was able to make advances in this case has never been solved, Adam has never been identified, and his killer has never been found. So that was just some of the characters in the course. This slide here shows you some of the other topics that we cover in the course. So if this kind of thing interests you, when you come to CBC, register for the forensic science course and learn more about these things. Thank you.
Thank you, Prof. Bates. Wow, that was so engaging. I was so captivated the whole time. It's not even a mock lecture, it's storytelling. Thank you so much for making the effort to create like a story out of everything and share with everyone. So you guys would like to learn more and hear more interesting stories, come join NTU's Chemistry Division. All right, okay, now let us move on to our Q&A segment, which we answer all of your burning questions. I hope you guys did ask some questions along the way, or else it'll be really awkward for me. Okay, let me have a look. Ooh, okay, we have a lot of questions. That's great. We will try our very best to answer all of them, starting with the first question. Okay, by Anonymous. Oh wait, they are all anonymous. All right. Saw from CBC website that students can take up modules that will lead to a concentration. Concentration, okay. So, what is the difference between a concentration and minor? Perhaps either of you, Prof.
Sure, let
Tan?
me give a take on it. Yes, concentration, that has nothing to do with the chemistry concentration.
Oh.
This simply is, originally concentration is a selection of a few courses that then allows you to get a concentration in, for example, food science or a green chemistry and so on and so forth in some selected topics. But we have, a couple of years ago, have since stopped doing that because we feel that a minor would be much more important. So the minor is the standard stuff that all students in NTU, if they want to get it, they can take up some courses that is from that minor. So you can have a minor in, for example, chemistry. If you're not a chemistry student, of course, you can have a minor in Korean, for example. You can have a minor in all sorts of different things. But just to cut the long story short, we no longer offer concentration because it's kind of like it's not so useful anymore. But the courses that is in the concentration still exist. So if students still want to take courses in food science, for example, medicinal chemistry, for example, it is still there. I hope that answers the question.
Thank you, Prof. Tan. So in conclusion, no more concentration, but there are causes and minors. All right, moving on to the next question. Will the lessons be conducted mostly through Zoom next year? Okay, I think this is a question for Dr. Zhang.
Yeah, so for the previous semesters and for this semester, we have been conducting our lessons online using Zoom because, due to social distancing and also the government's take that we should actually, avoid physical contact as much as possible. So classes that's bigger than 50 students, typically we have online lectures, which is through Zoom or through MS Teams. However, smaller tutorial classes, we are still able to hold them in person, but we have to abide with social distancing, right? So looking at current situation, the government has just changed to, phase 2 heightened alert. And then we are not sure how the situation will evolve for the next couple of months. But, if we are to be a bit more conservative, we will say that the lessons for big classes will still be conducted through Zoom. And for smaller classes, such as small size tutorials, lesser than 50 students, probably we'll still be able to hold them in person. And also for lab sessions, you are able to come for lab sessions as well, just that, we are able to only allow a smaller group of students for each lab session, and such that there is social distancing that can be placed in the lab as well.
Thank you so much, Dr. Zhang. So big clusters, probably Zoom, but small classes definitely can do it physically, and also lab sessions. All right, next question. Can I do summer research or any type of research activities in year 1 vacation period? Oh, Jing Kai, do you want to answer that?
Yeah, sure. Okay, so during year one vacation period, you are able to do summer research, and that will be a pass-fail module, meaning to say it will not affect your GPA. And for other research activities such as Eureka and Odyssey, those you are only able to do when you become a year two student. If you can't get summer or you can't do Eureka, you can always volunteer to be a helper in the lab. Yes, not helper, but like you will be attached to a student and you will be learning from that student, which are your seniors. Yeah.
Just to add some more, quite a lot of students actually after their first year, they would opt to do this summer research. That basically entails the students talking with the very friendly lecturers and professors to kind of like carve out a possible project. Typically, because it's the first experience in doing research, the expectation is not super high, right? So you're not expected to kind of like do some groundbreaking Nobel Prize winning kind of research. But of course, as all like things in life, you have to take the first step, and a lot of students will try to do that in their first summer holidays, which is kind of misnomer in Singapore. Of course, that means basically sometime from May to August. Yep, thank you.
Thank you, Prof. Tan and Jing Kai. So basically, if you have time and why not make the best use out of it, right? Go for a research program. Okay, next question. What is the difference between chemistry and biological chemistry versus biological sciences? How does their research aspect differ? Well, I'll open it up to the ground then. Does anyone knows the
I'll give it a take again.
Okay.
So in chemistry and biological chemistry, although our division is the name that way, but it's essentially looking at things, both chemistry and biological systems through a molecular approach. So in a sense, if I want to just be very kind of like not so fine-grained about trying to differentiate between biological science and chemistry, when it talks about biological subjects, in chemistry essentially is we look at biological systems from the bottom-up approach. We look at understanding proteins. We look at understanding COVID, for example, through looking at what molecules make up they are from. Whereas from a biologist approach, it was probably more from the top-down approach, looking from the bigger aspects and then zooming into the smaller one. Then of course, there will be the border between from the top-down and then the bottom-up. So of course, in chemistry and in biology, there's a lot of collaboration involved. And by the time you reach that kind of that zone, it's kind of difficult to say which is which. But I hope I give you an kind of like at least a general idea of the difference between looking at the biological system from the bottom up, meaning the molecular approach, and from the biologist approach from the top down. And hopefully that answers the question.
Thank you, Prof. Tan. All right, moving on to our next question. If we are a poly graduate, which modules in year one will we be exempted from? Is it? Dr. Zhang?
Just want to say. Yeah, so for poly graduates, currently we're working out to have exemption exam for you all to take, and if you do well for this exemption exam, then you'll be allowed to be exempted from the basic chemistry core modules in your year one. However, this is still in the works, so we are not sure if we are able to roll out this, this exam for the poly students to take for this semester. But for previous batches, poly graduates, we are unable to, offer you any exemption for year one modules. So, which may be good in a sense because, year one modules are basically foundational modules, right? So different polys, your curriculum structure may be different, and hence, our year one modules is basically to ensure that every student get to have, get to be up to the same standard, all right, such that they have a good foundation to move on to second and third year modules, all right? Because we strongly believe that in order to do well in your studies, your foundation must be strong, and therefore, the year one modules is to ensure that everyone gets a strong foundation before moving on to tougher courses in your more advanced years in CBC. Jinka, do you want to add more?
Thank you, Dr. Zhang. That is really true. Remember about my C grade on my biological chemistry module.
You're most welcome to come and take the course again with us.
Okay, I'll consider. Okay, next question. Will CBC graduates be able to venture into biology or biological sciences related industries? Ooh, I want to ask why you don't go to biological sciences, but that's a valid question. Does anyone want to answer? If you have any friends also or
Well,
Prof.
I
Tan?
guess I can try to answer this question as well. As I mentioned in the earlier question, sometimes the problems in biology and chemistry kind of like merge together. But having said that, chemistry students do find a lot of job opportunity in the biological science sector. For example, a lot of them are actually working in the pharmaceutical industry, right? Because like pharmaceutical industries are basically people who make drugs for medical reasons, and of course, but what are drugs in the end? They are basically molecules. So there's a lot of like jobs out there. What else? There's also the A-Star Institute, Institute of Biological, IBN, which is something to do with biology and nanoparticles that's hiring a lot of chemists. And also, for example, HSA, Health Science Authority, you may think that it's more like biological medical, hires a lot of chemistry graduates for analysis and also projects that has related to chemistry, and so on and so forth. So the short answer is yes. Quite a lot of chemistry students end up in doing biology, and in fact, some of them goes on to do a PhD in biology. That's also such instance, or even in medical fields as well. So that's also happening. And that has to do with because there's less and less of a silo nowadays in between discipline. And a lot of chemistry students go on to the other topics. And also vice versa, you do have biology students coming to do chemistry related work as well.
I think I wanted to ask did any of your like friends who graduated from CBC or are going to graduate, are they planning to go to any biology or biological sciences related industries?
Actually, most of my friends that found a job already, some of them are working like those pharmaceutical companies. Some of them, they are doing QA or QC for biological companies.
Ooh.
Yeah, so I don't know. I guess that counts.
Yes, so personally from a biological background, I've also seen a lot of my friends doing chemistry this time. I don't think it's that separated. And in fact, you might even go to an industry that has nothing to do with chemistry and biology, but they need people like this to be there as well. Okay, let's move on to our next question. How many unrestricted electives are we allowed to take? And does FYP/internship take up the elective modules? Hi, Jing Kai.
Yes. So I'll answer this. There is no fixed number, but there is a minimum number that you have to take. So let's say I already hit the quota, but I would still like to learn some other interesting electives. I can always apply for an overload, which is what I did. And for summer or exchange, you can also overload to take up some unrestricted electives. For the second question, no. FYP and intern are actually part of your major prescribed electives. Yeah, so those are under a different quota.
Thank you, Jing Kai. Oh, Dr. Zhang, would you like
so
to add on?
to further add on, the core curriculum of CBC and also for the major prescribed elective, which constitutes to the core curriculum of CBC, typically takes up 2/3 of your academic units or your credits, right? And you have 1/3 of your credits that you can take for unrestricted electives. So people who wants to do minor, for instance, can use these unrestricted electives to take up modules such that they can fulfill their minor requirements, which basically I think requires you to take 4 to 5 modules that is related to the topic of minor that you're interested to do in. Yeah, so like Jing Kai has mentioned, FYP does not constitute to unrestricted elective, but it constitutes to major prescribed elective. So there are 2 different kinds of elective.
Thank you, Dr. Zhang. Oh, I think you overload. Yeah. Wow, that's amazing. Good hustle. All right, moving on to the next question. How do we take forensic science course? Oh, me too. I want to know. Is it a core module or an elective? Prof. Bates, you may answer this.
Forensic science is an elective course. So it's actually an elective that is open to all students in the university. And for some reason, it's a little bit popular. Last semester we had, I think, 980 students. So it's an elective, it's open to everyone. So when your time comes to do registration before the start of the semester, you make sure you put down forensic science as one of your choices for an elective course.
Thank you, Prof. Bates. So, but first of all, you guys have to join NTU Chemistry. All right, for the next question. The AU for the core courses was increased from 60 AU to 63 AU from 2020 to the 2021 matriculation year. What changed? Ooh. Well, I would say either Prof. Tan or Dr. Zhang. It's a curriculum.
That's a very good question. Frankly, at the top of my head and our head, I don't think we know. But I guess we will try. Why don't you try to email us at the email address, or ask us in a Telegram chat group, and we will check it up for you. All right, because there's a lot of details that goes on, and sometimes we, with our limited human head capacity, we can't remember all these at the top of our head. I'm sorry. So yeah, email us or drop us a question at Telegram.
Okay. Oh, next question. I've heard about the compulsory internship from the Straits Times article. So will I have, and could I have, do both an internship and a FYP?
Yeah,
Dr. Zhang?
yes. So you can do an internship and FYP. So like I mentioned in the slides just now, if you intend to do FYP, all right, your final year project with us, then you'll be required to take a professional internship which lasts for 10 weeks, typically through your summer period, or like what Prof. Tan has mentioned, during the holidays in May, June, and July. Right. So this is to ensure that you still keep in touch with the industry while completing research in academia as well. So yes, you can do, you have to do both the internship, a small one, which lasts for 10 weeks, as opposed to a full-fledged internship which lasts for 20 weeks, if you intend to do FYP.
Thank you, Dr. Zhang.
Just to clarify, right? So all students that graduate will have to do a FYP or internship. So these two choices. But if you're doing FYP starting from this year, I think, you have to do a short internship as well. So basically it's package A, FYP plus 10-week internship, and package B, 20 weeks internship. That's essentially the choice that you get.
Thank you, Prof. Tan and Dr. Zhang. Yeah, I think they mentioned this just now. I never listened right. Okay, it's okay. Next question. Are poly students at a more disadvantaged position as compared to JC students? Hi, Jing Kai, you can take this.
Okay, honestly, I don't think so. So, because in the first year, the courses that we are taking is actually, I would feel, is sort of a bridging course to get everyone up to the same level. So, first year, maybe you'll be at a slight disadvantage, but if you're from a chemistry course, you shouldn't be. In terms of lab, I feel actually we are at an advantage. Yeah, no offense to the JC students, but in poly, we have a lot more lab experience as compared to them. So that would actually be an advantage for us when it comes to teaching labs, or even our research, like the summer research or your Eureka, etc. And then after that, when you get to year 2, year 3, year 4, there's no distinguishing thing between poly and JC anymore. Everyone is all about the same. Yeah.
Yeah, just to add on, I'm speaking as a Lao Jiao who has been teaching both poly and JC kids for the past 15 years of my career in NTU. So what Jing Kai says is roughly correct. Yes, indeed, the syllabus is designed in that way. Just now, Zhen Yang mentioned that the first year there are exemptions for JC students if you get good grades, whereas for poly student you may have to take a kind of like a exam to see whether you can make the cut to be exempted. So that basically is the point. So in a sense, the JC students probably would have an edge in the academic exam taking parts of the education, whereas the poly students, because of their experience, because polytechnic education provides for more practical approach to their training, would have an extra edge in their experimental skills because they'll be exposed to more, lab kind of practice and so on and so forth. But in general, after the first year, all these will be averaged out. Both sets of students will get the necessary training for them to excel well for the next step of their education. I hope that answers the question.
Thank you, Prof. Tan. I agree with what is, as a I'm from a JC background, but I think don't see this extra modules they take as a disadvantage. Take it as a learning experience, something to strengthen your foundation. And yeah, when you realize actually once in year one, you can see everyone's about the same. Everyone's just struggling to get through, and you will just grow and get better from there as a whole team. Yes.
That's another take. It's so difficult that it doesn't really matter. Nobody has an advantage. I'm kidding.
That's well said. Okay, moving on to our next question. Around what percentage of calculation, theory, and practical are there in the modules? Wow, I think it differs for every module actually, but Dr. Zhang,
yeah, I give some, again, I like to give general answers, and basically Zhen Yang can correct me and get more detailed things correct. Generally speaking, of course it differs from your the courses that you choose, but you probably would be thinking of roughly for the first 3 years of your education of the degree program to take about 1 whole day of lab per week. All right, that's a rule of thumb, and the rest of the days would be, you would say, lectures and tutorial. So roughly that's sort of like, if you do it that way, it's like 4:1 or 3:1 of your time versus theory versus practical. Yep. And of course, when you get to your 4th year, you're doing your FYP, things will change obviously. Then you spend much more time in the lab. Well, it depends. If you're a theoretician, you don't spend time in the lab. I guess that's a rough answer. Do you want to add anything?
Yeah, so I guess basically, we allocate a similar amount of time to do lessons or coursework in classrooms, and also undergraduate teaching labs, such that you can build up your hands-on skills. For calculation-wise, it depends, right? So depends if you're taking organic, inorganic, or physical chemistry. So for physical chemistry, probably more calculations, organic, less, more arrow pushing and such. So yeah, basically that's that.
Thank you, Prof. Tan and Dr. Zhang. I think you're in a chemistry division. You can't stray too far away from all these 3 aspects. But of course, as you get into year 3 and year 4, you can finally specialize on something that you enjoy more. Okay, our next question is, what is the benefit of taking a minor? Jing Kai, have you taken a minor before? Oh, okay. Would you like to share? What is the benefits in the student's perspective?
My minor is in Korean, so I'm not sure if it's very applicable here. But I think that if you were to take a minor in, for example, environmental science or bio or math, I think it will be much easier to find a job in that related field in the future. But for me, minor in Korean maybe not so useful. Yeah.
Okay. Yeah, your mind is in Korean. Perhaps Dr. Zhang.
Yeah, so that's a good thing about minor, right? You can really do a more in-depth study of a topic that is interest to you, that's of interest to you other than chemistry itself, right? It probably makes a more holistic education throughout your 4 years in NTU. So doesn't matter if your minor, is in Korean or in business, all right? It probably acts as a complementary knowledge to what you're actually doing, right? So feel free to take whatever minors that you're interested in on top of the CBC curriculum that you are really interested in. And also to not do a minor is fine, because if you are totally geek out about chemistry itself, doing basically hardcore chemistry is good enough, right?
Yeah, just to add on, again, Lao Jiao uncle kind of advice. You're in a university, you're supposed to try something new. So do something, learn something that you are not usually exposed to, right? Taking a minor is one possibility. So yeah, go and do a minor, I would say.
Thank you, Prof. Tan and Dr. Zhang. Yes, Jing Kai, Korean is useful. You can go to a Korean lady and 예쁘네, 귀요미네, 잘하네. Yes. There's always a use for whatever you are studying. Okay, next question. I would like to pursue forensic science in the future, Prof. Bates. You can already see your cohort growing. Are there many graduates who also decide to pursue this field? He's worried. Okay, Prof. Bates, you can take this question.
Yeah, there's always a number of students who want to continue in forensic science and have a career in forensic science. So, but the problem is, this is Singapore. We have a low crime rate. And one of the bad things about a low crime rate is that there are not many jobs for forensic scientists. So the main employer is the Health Sciences Authority, and they hire a small number of graduates each year. And certainly some of our graduates are now working as forensic scientists in Singapore. But low crime rate, so not that many jobs in this field. And so that's why the forensic science course we have is intended just for interest rather than to prepare you as a forensic scientist. But if you do want to be a forensic scientist, then a good chemistry degree is a good preparation for that career.
Thank you, Prof. Bates. And I think there's a lot of things to learn in the forensic science called like critical thinking skills, analytical skills. So if it's just for interest, please do take it. I would take it, yeah, but I can't. All right, moving on. Do the exemptions for the foundation courses only apply for A-level students? How about IB students who have taken higher level chemistry? Ooh. Prof. Tan or Dr. Zhang?
Well, I can try. Currently, because A-levels being the majority of the students coming in, we have kind of like systemized it and clear policy about it. For the IB student, is still not that many. So we think currently the practice is to do a case-by-case scenario. So drop us an email. That's the standard answers that for questions that we don't have no answers currently. So drop us an email and we'll check on it and we will give you the answer that way. Yep.
Dr. Zhang or Prof. Bates, would you like to add on? Oh, no. All right. Okay, moving on to the next question. In one semester, how many modules do we take on average for core, major, and electives? Ding, ding.
So in your first year, normally on average we take about 6 modules. Yeah. And when it gets to your third year or fourth year, you'll be taking lesser modules. So major, I think by major you mean like major prescribed electives, right? You can only take those in year 3 and year 4. And we only need to clear 4 in total. So if you split up your load, is in year 3 and year 4, you're taking about maybe 4 to 5 modules. And you have to bear in mind that one whole semester has to be set aside for your internship or your FYP. So with FYP, you can take, I think, another 1 or 2 modules together with that. Yeah.
And that's for non-overloading, right? Because we've got like a high flyer here.
For
so this is
non-overloading.
kind of like on the average.
And also for the core modules, right, typically you will take 1 to 2 core modules per semester, right? If you are really, really smart, you can take up to 3 or more, but it's ill-advised because for core modules, in case you want to overload and graduate early to save money, it may not be a good idea to do so because the content is pretty heavy. So unless you're really, really, really good in your studies, don't try to overload your core modules.
Thank you, Prof. Tan, Dr. Zhang, and Jing Kai. All right, next question. Prof. Bates, more of your students. How do we take up forensic science after entering this course?
Very, very simple. You graduate with a good degree and then you apply to the Health Sciences Authority for a job. Very simple.
Oh, I think the question meant like when they enter NTU chemistry, is it?
Yeah. Entering the course.
Entering the course. So,
Oh.
new
Okay.
students.
How do you get the course? It's an elective course. So when you do your course registration before the start of the semester, you put down forensic science as one of your choices as an elective. So it's built into the course registration system.
Yes, it's that simple. But good question. more of your students showing up. Okay, moving on to our next question. Will second major opportunities be open to students who enrolled as a single major but have decent results after year one? Dr. Chan?
So for second major opportunities, I have to say that they are actually very selective and exclusive program. So we have only like a handful of students. For instance, for food science and technology, we open up to 10 to 15 seats per academic year, and for business as well, and also for environmental sciences up to 5 year. So for food science and technology, you are allowed to, if your results are good enough at the end of the first year, then we'll offer you a chance to take up food science and technology. However, for second majors in environmental sciences and also business and international trading, they are based on admission. So upon admission, you need to take out this second major already, because in your year one, you'll be taught modules in that is related to this second major. All right, so long story short, if you are taking food science and technology, you're considering that, then yes, you can take up that at the end of your first year. However, if you're considering environmental sciences and business and trading, no, you cannot do that after your first year. It's upon admission.
Thank you, Dr. Zhang. All right, we have next question. Ooh, can we hear more about the alchemy to chemistry module? It sounds like so much fun. Oh, do you have this module?
Yes, I do.
Oh, Prof.
So
who else?
by some chance, I'm the person who teach that, and I must say that it's the second most popular course in chemistry after, of course, forensic science. And it's actually a pretty interesting course. It's actually a general elective course, and it's open to everybody in the university. But of course, you need to have some basic chemistry knowledge. It actually connects history and chemistry. It's basically the story about the development of chemistry through the ages, from the ancient times, from the ancient Greeks, the ancient Chinese, the Indians, ancient civilizations. How did chemistry came about to be the modern chemistry that we have? So if it sounds interesting, again, like what Rod would say, come to NTU and you can hear more about that.
Thank you, Prof. Tam. That sounds so exciting. I want to go for it too. Oh, next question. Is this the correct course to take up if I want to enter pharmaceutical or healthcare industry in the future? Well, we did answer this a bit, but we can add on. Anyone would like to add on?
Quick answer, yes. But of course, it really depends on exactly. What we can say is that we do see that a lot of our graduate students who graduate find jobs. As Jing Kai mentioned already, some of his friends found QA, QC job in pharmaceutical industry. So you for example, you are talking about Pfizer, you're talking about GSK. So we have students who are at the managerial level, as well as in the production, as well as the QC, as well as the validation, as well as like the research science lab level. So yes, for pharmaceutical, definitely. And healthcare industry in general, we do have some of our graduates maybe working, like a management associates or management levels in hospitals, for example. Of course, the scientific training will be very important in all those this kind of industry. So I guess you could say it's not a wrong choice to take if you want to end up in the pharmaceutical healthcare industry in the future.
Thank you, Prof. Tan. All right, next question. How much heavier is the workload for double major programs? Are the modules for the double majors only taken from year 2 onwards? Perhaps Dr. Zhang, would you like to answer?
Yeah, so for food science and technology, yes, you take your double major program modules from year 2 onwards. But for the other 2 second majors, which is in environmental sciences and also in business and international trading, you take them from year 1 onwards. So for every single semester, probably you take 1 to 2 modules on top of your typical curriculum that non-second major would take. So if you were to do the calculation, per semester 1 to 2, 1 year there's 2 semesters, and then you have 4 years, which is 8. So 2 times 8, which is 16 extra modules you have to take on top of what you do as a normal 4-year honors course in Bachelor's of Science. So 16 extra modules on average for double majors.
Thank you, Dr. Zhang. All right, next question. You mentioned that it is okay to fail experiments. Or him, not me, him. But will grades be affected if our FYP/research experiments keep getting negative results? Jing Kai.
Yeah. So I feel that in research, it's normal to not always get results because that's what research is about, right? It's always about finding new things, and I think most important, your grading. This one I'm not very sure because I'm not the one marking my FYP. But what I feel is that as long as you're able to justify why you get these results, or you can come up with a possible solution such that you are able to get positive results in the future, then it should be okay. Yeah. It is normal to fail in research, but doesn't mean that you should always fail. Yes.
Yeah, of course, like as Jing Kai say, research is, basically 80% failure and 20% success. And we do not mark down students just because their experiments all fail, right? It's a learning process. And of course, that's why you have a mentorship program. Your research advisor, your mentor will be, around you talking with you about the research progress. And of course, he or she will understand if it fails, why it fails. And if you know why it fails and all these things, it is a learning process. And that the design of the experiment, the analysis of all these are the things that's being graded. It's not just simply about whether you got like 100% yield for your reaction or not, right? So rest assured, it is not so superficial as in whether if you get 100% yield for your reaction, you get A. No, not such thing. It's much more subtle than that.
Thank you, Prof. Tan. In fact, I feel that failure is a result in itself, and you can learn from it and what works and what does not. All right, for our last question, of course, we will keep it for Prof. Bates. I took a specialization in forensic science in Polytechnic. The modules I took seemed to focus on analytical machines and techniques. Would it be similar in NTU? And would you agree that experience in those analytical techniques would be helpful in other jobs?
Okay, this is a great question because it shows the difference between poly and university. So the main job of poly is to train people to fill particular roles in industry, which is why they focus on the instruments and the techniques. But university is about training people how to think. So for the forensic science course that I teach, the focus is on the cases, the focus is on the critical thinking, and the focus is on the logic of how the case was solved. So there's the difference between the Polytechnic and the university. Now, the second part, would I agree that experience in these analytical techniques would be helpful in other jobs? Absolutely, yes. The more experience you have of using more instruments and more techniques is going to be valuable to you. More experience open more doors for you in terms of getting jobs. So that's why you come to CBC, you can get hands-on experience of GC, HPLC, NMR, all sorts of instruments will be available to you to use, both through the formal lab courses and through the different research experiences that you can take. So yes, the more experience you have, the better for you.
Thank you, Prof. Bates. Unfortunately, just like life itself, all good things must come to an end. That's all we have for SPMS CBC's e-open house. You guys have any more questions, you may do your questions to CBC's Telegram channel at NTU_chemistry. Also, don't forget to scan this QR code that you're seeing on your screen right now for a feedback survey form to let us know what you think about SPMS e-open house. You may also check out the official SPMS website for a 3D virtual tour of the SPMS building. Thank you all for joining us this morning. I hope you enjoyed the session as much as I did. Goodbye. Just keep thinking. Have your lunch. Hungry.